Hello everyone, welcome to my office and welcome to my first of a series of videos that is about mathematics, and they're going to be different to what you've seen on the internet up until now. A lot of videos on YouTube in particular are how-to mathematics, how to do fractions, what are fractions, how do they work, blah blah blah. But this is going to be slightly different. This is going to be why fractions. The reason I'm doing this is, like, I had this conversation with some of my students. I'm a high school teacher, and still you always get asked the question, why do we need to learn this? And that's not an easy thing to answer. So here is my attempt to. So what this video is going to be about is we're concentrating on fractions, as the title says, but we're going to be looking at why do we need to go beyond this is a fraction, isn't it pretty? You learned that in primary school. So why are we teaching fractions all the way up until grade 10, 11, 12 and beyond? Why is this a skill we need to practice over and over and over again? So let's get started. All right, so welcome to my pseudo whiteboard, which is really just a notebook because I like to draw and this is the way I do things. So we're starting our lesson by looking at why fractions. Why do we teach fractions? Now, there are plenty of YouTube videos across the net that talk about, well, why do we learn them? Well, you learn so, like, if you have a birthday cake and you want to cut a piece for everybody, you know how many pieces to cut, whether to cut it into, like in this one, into eighths or whatever, or how to share a pizza and how many slices you need to cut, right? That's what fractioning is. It's taking a whole and dividing it up into parts, right? So when you look at a third here, and this is the number we're going to be looking at all the way through. I'm going to use the third as my stand-in fraction. What a fraction really is, we're looking at one part out of a total of three. So a third is one out of three parts. Interesting thing that nobody I've seen ever talks about or thinks or has noticed is I've got the division sign here. Now, has anybody ever noticed that a division sign, which is the first thing you learn in primary school, or one of the first things you learn, you've got a line with two dots on it. Whereas a fraction, you've got a numerator, a quotient line, and a denominator. Numerator, quotient line, denominator, right? Because it's the same mechanism. What do you do when you divide anything? You're breaking it up into smaller parts. So these are directly related to this. You learn this first in order for you to be able to do this. Right? So when we look at the idea of a third, 1 over 3, what we're really doing is we're taking one thing and dividing it into three parts. This is also, incidentally, how you convert a third, the fraction, into its decimal equivalent. That's another lesson. So when you are looking at a third, you're looking at one thing that has been divided into three parts. Now, that's all well and good, but why do we continue to learn this beyond primary school? Why is it when you get to grade 7 you have to do fractions again, and then grade 8 and then grade 9? Why do fractions keep on turning up? Because we use fractions to describe a whole range of things in mathematics. And you need to be able to understand the connective tissue between divided sign, two fractions, to the next level, to the next level, right? The fractions is really just the beginning. Let me show you. Right, so let's look at probability, right, which is one of the first things you learn. So probability, or in other words, chance, it's a mathematical science of chance. What is the likelihood something is going to happen? you already know, you are brought up knowing a lot of this already. You instinctively know it, right? So here's our friend the third again, when we talk about a probability of 1 in 3, so instead of saying 1 part of 3, like we did before, we now say you're looking at 1 chance in 3, right? So a lot of people associate probability with gambling and that sort of thing. But so that's why I use the notion of the dice. So if we look at a 1 in 3 chance of winning, right, what we mean is, well, you already know what that means. You know that it means the chances of you winning is not impossible, but it's not great. It could be better, right? We know this. We know if you compare it to a 1 in 6 chance or a 1 in 20 chance, you know this is a better option. You've got more chance of winning a 1 in 3 than you do, say, 1 in 16 or 1 in 20. Right? A lot of this has got to do with context as well. Right? Where are you telling the story with probability? So if we're talking about a 1 in 3 chance of rain, well, that's different to a 1 in 3 chance of, let's say, winning a football game. Right? It means the same thing. You've got a 1 in 3 chance that it can rain. But this also means a good thing. Right? It means you've got a chance of actually it not raining, so you can go ahead with whatever activity. Right? Whereas here, you may not take the risk, but in this case, you will. Now, calculus is another place where fractions turn up. We use the same mechanism as a fraction. It'll even look like a fraction. But we use it slightly differently. So in calculus, we look at the slope of a line. The slope of a line is worked out as rise over run, right? So the rise is how many units up does something go for how many units across does it go. So if something's got a slope of 1 in 3, which means for every 1 unit it goes up, it goes 3 units across. So it will look something like this. 1 unit up, 1, 2, 3 across, there's your slope, right? Same mechanism, works exactly the same. We see it as a slope of 1 in 3. I can go on all day, and there are other examples of where the idea of a fraction keeps turning up, right? It's all about comparing one thing with something else, or one thing being a part of something else. So when you look at rates, so here, for example, we've got kilometers per hour, right? So many kilometers for every hour. So this is the same idea as rates, as slopes. Sorry, my bad. As slopes, right? 1 unit up, 3 units across. So many kilometers per hour. We look at ratio, right? We see ratios as like this, but we can also write them as fractions, right? We see these on maps, or if you're into scale modeling or anything like that, you've got a rate or a ratio of 1:100. Let's say if this is on a map, you have 1 centimeter on the map will represent 100 centimeters in real life. It's one part of a whole. Now in school with fractions, you're going to be asked to add them, subtract them, multiply them, divide them, and be able to manipulate them, right? That's how to use the tool of fractions, because you can use them to make other parts of maths understandable, easier, right? It's not just about being able to do fractions, it's about being able to understand them. And I hope what you've just seen helps you understand where fractions keep turning up in other forms, so that you can understand how to do these next levels better. Thanks for watching. If you liked what you saw, hit the subscribe button and If there's any other math things you want to understand a little bit better, let me know in the comments. Catch you around.